Okay, the overall content for the day is actually first, we are looking at the overview of the heritage buildings conservation. Then we will look into conventional approaches of heritage buildings conservation. And then the main idea of today's topic is digital approach of heritage buildings conservation. And will follow it will be followed by historic building information modeling is on the move. Finally, way forward of heritage buildings conservation. Now, let's start off with the first subtopic, overview of heritage buildings conservation. Heritage buildings are very essential. They represent cultural identity and historical values. It also contributes to the emotional ties to the people and sensitivity towards the past. It provides evidence that provides educational opportunities, and it also presents the values worthy of learning. So this is the overall idea of heritage buildings. Now, the UNESCO had actually identified more than 1,000 World Heritage Sites. If you look at the data here, it is separated or categorized into different regions. The total of it is more than 1,000. Most of the heritage sites are actually located at the Europe and North America, with a total of 514 sites. And this is followed by Asia and the Pacific. There are 258 heritage sites. So these heritage sites is not only limited to building, and they are actually categorized into cultural, natural, and mixed sites. So it's not only on building. Now today's focus, because we are from Malaysia, so most of the case studies for today is actually from Malaysia. So heritage buildings in Malaysia is actually, these are the numbers that we can see based on the different states in Malaysia. So if you scope down to the Malaysia, there are approximately 21,000 heritage buildings in Malaysia that were built between the year of 1800 and 1948. According to our Malaysia National Heritage Act 2005, heritage buildings can be defined as buildings that are highly valuable assets due to the historical values and tourism potentials. Paramount to conserve these buildings by continuously caring and protecting them from being destroyed to prolong their lifespan and functions. It is quite natural that the buildings age. They will be exposed to serious building defects and deterioration. Those buildings involves effective and efficient utilization of resources in the continuous care and protection of building elements. To keep them in order, we have to maintain the building fabric and its services. Effective conservation is essential in extending the life of the building and avoiding the need for potentially expensive and disruptive repair works. And it is more than just architectural considerations. It also involves economic and social issues, which include sustainable management of changes. Now we move on to the conventional approach of heritage buildings conservation. Before the digital approach, we have been using or we have been utilizing the conventional approach in conserving the heritage buildings. So let's move on. Globally, there are 5 main keys of good conservation practices. So these are the 5 main keys. The first one is minimal intervention of it. Through this practice, we need careful recording and research. We respect the quality, and the preference is given for the original materials. In terms of sustainability, we look into the permanence in finished work. We need a well-defined maintenance plan and a long-term protection. The next key criteria that we are looking at is minimal loss of fabric with minimum alteration. We avoid to beautify it, but to maintain it, and the preference is given for the least possible loss. In terms of legibility, there's a distinguishable use of new and additional materials, and we avoid falsification of elements. Lastly, the fifth practice is reversibility, where we look into reversibility of intervention and allow for correction for unforeseen problems. So these are a few countries or a few areas that they have practiced these practices internationally with different considerations of practices. For example, in New Zealand, they focus more on minimal intervention and minimal loss of fabric. Amsterdam, they focus on sustainability and legibility. So different area or different place in the world practices different criteria. Now, in the context of Malaysia, there are 4 keys of good conservation practice, which include minimal intervention. This include the respect for the existing fabric, use, associations, and meanings of the building. Cautious approach have been taken as much as necessary, but as little as possible. Researchers here in Malaysia conduct scientific research and laboratories testing, which appropriate research and physical investigation, and preceded by appropriate research, investigation, and recording. And there are full documentations of conservation work. Conservation records should always be maintained, kept with the documentation of the building or site. Lastly, Malaysia applies effective methods and techniques that make use of all the knowledges and skills and disciplines that can contribute to the study. So the conservation plan is actually based on a well-developed policy to protect the building's significance without jeopardizing their future development. The plan also includes an understanding of the buildings itself, the sites or the place, and cultural significance. There's a need to have good written policy and fair judgment on the vulnerability of the site significance, and the plan is developed based on its fundamental association with the significance of heritage properties. Now, let's look at the process of how buildings are being conserved. The first stage of the process is to identify the importance of heritage. Of course, to identify the importance of it, there are preliminary studies that we can carry out. Okay, so what we study is on the location of the building, historical backgrounds, values, current condition, and the owners of the building. So these are the criteria or the perspective that studies are actually carried out in the preliminary studies. Then we move forward to the next step, which is documentation, where it takes quite some tedious process. In which we look into the lab report that identifies the types and level of defects, as well as the proposal of conservation methods. And of course, the as-built information that has the actual drawings and information of the buildings to be used for scoping down the work, method and techniques of conservation and cost estimation. The next step we carry out is the preparation of the action plan, where we form the work scope, scoping down the work of conservation, planning what are the types of works that we are going to carry out. And once the plan itself is, we can say it is confirmed and verified, then the final step will be managing building and site. in which the implementation of conservation programs will be following the guideline, reporting, recording, and all the documents that we have mentioned earlier. So now let's move on to see what are the elements that we usually conserve within the building. Now, first thing, we are looking at doors and windows. Are there any missing parts, deterioration, broken panels? For ceiling, the normal or the common problems will be humidity, fungus growth, broken panels, and peeling paint. So painting is something very normal. It is very common elements that we usually has to take into consideration. Roof problems, most of the roof problems are deterioration and termite attack, and rainwater downpipe. Wall, the common problems are humidity, crack, soil movement, deterioration, thermal effect. Plasterwork decoration is somewhat a must practice in conservation. And floor, broken panels, deterioration. Staircase is something very common in defect. So what are the factors that contribute to effective conservation? First, of course, we have to look into the amount of money that we have to spend in order to conserve the building. And the next one is to look for similar materials and resources in order to maintain, not beautifying the building, but to maintain the overview or the overall of the building. We normally look for what has been used ages ago, years ago, so that we maintain the same material or same resources. Different from new building works, it is not something like we built from scratch. It is more on conservation, more on restoration. Then we look into the next factors that is affecting the effective conservation is actually the responsibilities of the team. So who is taking care of which part? That is also important, and the whole team would have a very clear mindset of what they are doing. The next important one is the skilled and unskilled worker, because we are going to maintain it. So we need the workers that has the same mindset with us. And direction, idea solver, this is mainly the project director or the main key, or the key person who actually brought up this idea and guarantee safety. So what are the issues surrounding conservation? There are a few issues that lead to these difficulties in conservation. Now, it is very often that owner doesn't prioritize the heritage building, which results to the badly decaying state of the building. There is also lack of understanding and appreciation on the heritage value of the buildings, which is the main factor on why the owners feel reluctant to carry out a proper or systematic maintenance work. Of course, this also because of the amount to be spent for the conservation. So all these factors are actually categorized into 5 main issues, which is technical, management, human, financial, and environmental. Technical issues include not only considering the maintainability analysis, not using life cycle costing, usage of new material, usage of substandard material, poor quality control, as-built documents, not reflecting actual status of the building, and poor resources. Management issues include poor management, lack of uniform specifications, lack of uniform contract, shortage of maintenance contract period, lack of coordination between the management and technical groups. Human issues forms when there's unavailability of experienced people, lack of skilled manpower. Importance of conservation were not understood by the public. lack of awareness, misuse of facilities, miscommunications between the groups. Financial issues is something very common where owners do not get financial support. Works are very expensive and restrictive, and they have cost control and budgeting issues. Environmental issues include increasing demand for new developments. Most people look for modern buildings to boost the economy, to help in development of the economy of a country. Changing needs for social and economic well-being of the people. Not all buildings are at risk are actually designated as conservation areas, so support is less. Now, based on an analysis towards 209 heritage buildings in Malaysia, it was revealed that most or majority of the buildings are actually occupied. Okay, so not many are demolished, not many are abandoned, but most of them are occupied. However, most of the buildings are not being conserved properly. 74% of them were not conserved properly. 61% of them are actually in poor condition, and most of them are having major building defects. So these are the analysis from the research towards 209 heritage buildings in Malaysia. So let's look at what is the perspective of quantity surveying or cost engineering here. We focus more on the opinion of QS or CE. From the analysis or from the previous works, we know that most of the quantity surveyors or cost engineers perceive conservation works as risky, okay, riskier than new building works. It requires non-standard scope of works, different approach, special management experience, so it is new experience. It is also insufficient for QS to prepare tender for conservation works by merely using standard documents for the new buildings, because it is totally different from new building works. And what happening in construction is ill plans have actually caused cost overruns and contractual. Now we can understand the QSs do not involved in conservation while the other half involved. However, all of them, all that participated in the research would want to involve in conservation works. But we also find out that there are challenges faced in these conservation works. These challenges faced have been categorized into a few categories, from information-related challenges, people-related challenges, legislation-related challenges, knowledge-related, health and safety-related, uncertainties-related, and approach-related. There are a total of 30 challenges that have been categorized into these 7 main categories. And if we look at the previous research that we have carried out, the most severe challenges here are these 6. The first 3 are the significant one, and the last 3 here, this last 3 that we have listed here, has the same severe index. So they have almost the same severe index. Okay, the most severe challenges here is actually the requirement on specialized consultants. And then the second most severe challenges is lack of as-built drawings, followed by unknown risk. That requires great amount of information for architectural works, failure to select capable contractor, availability of relevant skilled workers. So others that were not listed here were also being categorized as challenges, but they are not going to be discussed here. Now, let's look at this specialized consultants. Heritage building conservation work requires different methods and more attention in the process of conservation work because the work is carried out in a limited space in the building. So this conservation work requires more specialists or professionals due to a lot of uncertainties and risks involved. It should be carried out well, and professionals should be involved in this conservation work to achieve the required quality, as well as to avoid the decrease of values in heritage building. The next one is about lack of as-built drawings. Because conservation work is different from new building work, drawings from the new building are usually available. However, drawings from heritage building conservation are often due to buildings are old, especially those very old buildings. Drawings and specification are estimating the piece of work. Undoubtedly, lack of as-built buildings will cause professionals, especially quantity surveyors or cost engineers, difficult to forecast all the work needed during the tender period for the conservation work. Okay, then let's move on to unknown risks. There are a large number of risks in heritage building conservation work which cause the quantity surveyors produce an inaccurate initial and final cost estimate. There should be a collaboration among professionals for an effective way of sharing knowledge in heritage building conservation work in order to share the risk of conservation works. So the professional teams should actually be capable of identifying potential risks through their past experience and carry out site investigation, a few times of site investigation. Then the conservation work is able to be defined, and this will be the best way to control the risk. If we look at the requirement of great amount of information for architectural work, we know that heritage building conservation is often difficult and complex practice, and it has unique architectural elements. This architecture of heritage buildings requires extensive information and knowledge, and is always complex. The complexity involves irregular shapes and complicated design. So this will also affect the accuracy of quantity taking off and will cause inaccurate cost estimation. And then about contractors and workers, these are people-related challenges. We believe that in the context of Malaysia, there are lack of skilled workers due to technical practice involved. We are also facing this problem on having an experienced contractors in this relevant field, which is who are equipped with proper management skills in order to perform practices, conservation practices for the projects. So these are a few challenges that we face here. So what we can actually look into the conventional approach carried out is through a few processes, okay? So before embarking on any physical intervention or design strategy for a potential conservation project, it is essential to assemble the availability of the evidence on the building. So the first part is actually the historical research that is available for us. We are looking at the different sources of data, report, and research from the research aspect. Then from the research, from historical research, we can actually identify the documentation that we need. For example, measured drawing. We know that a lot of architectural students actually start off from measured drawing. Measured drawing or as-found drawing means a set of line drawings that will accurately delineate the subject of the building in existing condition. The measured drawing will illustrate the interior and exterior of a building, including the structural design. It will also illustrate the defect areas such as cracks in plaster and missing elements. Documentation that was kept in the research is very useful before we carry out the next step of the survey. Then DLAB survey. DLAB survey that produces a DLAB report is actually a practice of identifying the recording of building defects through the means of photographic and digital documentation prior to any conservation work. The core of this DLAB survey is the process of walking through a building to gather and record information based on observation of the finished surface and any exposed structure. So in the practice of building conservation, DLAB survey are generally instrumental in regard of the following aspects. The first one is to understand the state of the building defects. Okay, we have to know what are the defects that is occur within the building. Then we need to determine the causes of the defects. Then we identify appropriate methods and techniques of the building conservation through knowing the causes of the defects. Then we provide reference materials to the client or the owners, consultants, and contractor. So to be effective, the practice of DLAB survey should involve a multidisciplinary approach which requires in-depth knowledge in conservation as well as some other related fields like correctly assess building defects or to determine the causes of proposed restoration methods. Then we will look into the material and structural report. Then carry out preliminary conservation works. Okay, so there are two stages here for investigation. We can have site testing. Okay, we can test the material and their condition. We can also have lab testing for material to actually for those that can analyze using naked eye. So there are two ways of doing investigation. So after diagnosing the defect of the heritage building, the conservator will prepare the proposal. Okay, the proposal will include a method statement of the technique to repair or to conserve the heritage building. So major conservation works will start after the preliminary conservation, guided and monitored by guidelines and standards by the Department of Heritage of each country. So conservation works can be actually categorized into a few stages or a few types, from preservation to repair and conservation, or maintenance and treatment, or restoration, or dismantling and relocation, or reconstruction, or record before and after. So this conservator itself will identify what kind of conservation works to be taken. And finally, the final report would have to be produced to record or to put in all the overall process of the building conservation as an evidence for future references. So this is the overall steps or a process in conventional approach. So now let's move on to see or to identify or to distinguish the digital approach, which is very different from what has been carried out as conventional approach. So let's look at the digital part of the heritage buildings conservation.
Okay, thank you, Dr. Mei Chuan. Hello, everyone. I'm Amira. Okay, so let's proceed with the next segment, which is digital approach of heritage building conservation. Okay. So this is some introduction, right? So, okay, we know that BEAMS calls for coordinates different professionals in terms of modalities, organization, and also construction. So, or we call as heritage building information modeling, or also can be called as historical building information modeling, and in short form as a HBIM. Okay, it's a new concept of architecture engineering and construction industry. But the potential is bring benefit to architects, conservators, facility managers, engineers, contractors, or even to QS and cost engineers and others. So HPM is relatively new in construction industry, and it involves a BIM applications. So when we venture into the HBIM, the first thing that we have to know is the BIM tools. That's the most important. Okay. All right. So if you look on the introduction of HBIM, so the second introduction, which is produce intelligent board objects and models, contains managed information that can be updated, replaced, and added. So in this term, later we will go through how the process from the scanning and become a 3D model. So from the 3D model, we can produce the intelligent models, objects or elements that contains data information, okay, and also the related information. And also it given us attributes of HBIM, which allows a clear and reliable visual display. And these are some of the benefits. There are a lot of benefits of HBIM, but I will show you some of the benefits of the HBIM. The most important is allow study with new structure, because we know that the heritage building has been built many years ago. So there are some structures, some methods that we cannot find anymore in this current world, right? Okay, we go to the next slide. Okay, pillars of HBIM. Engaging people during HBIM implementation is vital, and we have 4 types of pillars. So so the first pillar is non-specialist. So specialist with terms in management of a committee that must set policy to start the technology. And the non-specialist, the one that benefit the technology. For example, like architects, contractors, facility managers, and others. Okay. So the second pillar of HBIM is technology, which is either hardware or software. So hardware, we focus on the devices that are going to use recent surveying, so laser scanner or maybe a high-spec computer. Okay, whereas software, we focus on the building smart open platform that allow further integration between digital and also the data information. For example, like using a Tekla structure. Okay, this is the BIM software. Tekla structure, BIM Revit, Autodesk Revit, what else? Bentley, Archicad, and others. Okay, the next pillar is process. So process involved in modeling and integrated. So in terms of process in modeling, so you're going to gathering all the information to the relevant of building management for like BIM. And then integrated means that related to the process of architecture, engineering, and construction industry that we already know, such as standardization, interoperability, integration, collaboration, documentation, automation, and many more. Okay. Okay, the last pillar is policy. Okay, with the policy is for further analysis, management, and control. Okay, for mandate and protocol guides. Let's say, for example, like for mandate, sorry, is that everything okay? Right. Okay, through mandate and protocol guides. Okay, let's say, for example, in order to reach the goal, in order to ensure that you reach the objective, so it's vital to have the policy so that it can be as a requirement, it's a guideline on how to do the HBIM process. Okay. Right. So these are the pillars of HBIM. Okay, HBIM is usually divided into 2 workflows. So we focus on data collection and also data processing. Right. Okay, activities such as data collection needs to be carried out to have a better understanding regarding the historical building. Okay, this stage. Is everything? All right, so let's continue. Okay, so for data collection, okay, this stage is mainly to gather the tangible assets such as length, width, height, okay, and also other relevant information of the building itself. Okay, and then for data processing, it's more towards to the modeling based on the data collection. This part where we're going to convert the point scans that we have scanned of the building and become a 3D model. So we will go through it together after this. Okay, in HBIM process, we have three stages. We have data collection, we have data processing, and also data synthesis. So in data collection, we focus on the collection of historical building data. Okay, later we will going to go through one by one process by showing you some example of the case study that we have done. Okay, for the data collection, the first step for HBIM begins with survey historic building. So in order for you to start to do your HBIM or to collect the data of the historic building, you need to survey what type of building you want to do. Okay, you just don't simply go to the any historic building to do a scanning. There must be a purpose why you want to scan or why you want to have the data from that historic building. Okay, so the second process is data processing, which once you have scanned, once you have collect all the data collection in the first stage, you're going in bring all the data collection into data processing. So in here, we're going to play around with some softwares. We're involved in Revit, Scene software. Scene software, if you use the name was Scanner Faro, so I will show you later. Okay, or there are many types of tools to scan, or maybe you can use drones and others. Okay, and when it comes to data synthesis, where you're going to create a 3D model. So we know that BIM is a process and also to manage the data information in 3D model. So in data synthesis, where we're going to get the information for a 3D model. Either you want to do some measurement, you want to create as-built drawings, or you want to do some costing, you want to do some changes on any elements or materials in 3D model. Okay. All right. Okay, so HBIM locally, this is a part of our case studies. So what we have done is we identify some of the historical building. So at the moment, we already scanned about 6 history building in Johor Bahru in Malaysia, including temple, church, and also some few museums and also school. Okay, and then once we have scanned the building, right, we are using 3D laser scanner from Faro. So there are many vendor. So we are choosing Faro. We are using Faro X330 and using a Scene software. It comes together. So Scene software, the purpose is to merge and stitch all the point scans that we have scanned from the historic building and become a point cloud. Okay, I'll show you later. And then after the point cloud, you're going to have the IFC file or RCP file that are going to convert or link into Autodesk Revit or any other architecture software. Okay. So this is an innovative approach. All right. Okay, it's a similar one. Okay, we will go one by one for each stages. Okay, for the first stage is the data collection. So when you identify after you identify which type of historic building or heritage buildings, okay, first of all, you need to visit the place or the area to find out where is the place, to find out whether it's safe to do or not, to check the condition of the building, all right, in terms of the safety, in terms if the some of the buildings abandoned. So when so for example, like us, we went to this Johor Art Gallery. It's an abandoned building, so no one is there since a few years ago. So it's very dangerous if you come alone. So that's why you need to bring some of your colleagues together to do some site surveying or also do the scanning. Okay. Once you collect the building, they identify the building, you need to do some layout planning. Layout planning, at least you need a floor plan. Okay, for example, let's say the Ministry of Tourism or a government don't have the floor plan of the heritage building, we ourselves, we can do our own floor plan, right? So we just visit or enter the building to see how the floor plan of the building. So what's the purpose of the floor plan? Because we need to match to other, we want to put is the scan points we want to put, and also for the targets. So the targets, if you look at the bottom of data collection, it shows that spheres, checker box as a reference. So in terms of our case study, we are using sphere. Okay, sphere, if you look at and on the photo is the one, the white sphere, white ball. Yeah. Okay, that's a sphere. Right. So this is a summary case study, Johor Art Gallery, okay, Johor Old Chinese Temple, okay, and Church of the Immaculate Conception. Johor Art Gallery has been abandoned for many years, okay, so the government also don't know what to do with the building itself, okay. So it's like a chance for us to do to collect the data, okay, get some scanning, and after that we give back the data to the government, okay, so that maybe they can use it for any renovation, retrofit, right, refurbishment and others. So like for Chinese temple, it's still using by public, right? We did that during a weekday, so many people came to pray, and yeah, it's a bit challenging, but it's fine, okay? And then the next one is the Church Immaculate Conception. Yes, it's open to public as well, okay? All right, the second stage, which is data processing, okay? So data processing, once you have the scan points, for example, like let's say I have one building, I have 20 point scans, and then this 20 point scan, when they enter to data processing, we are going to use Scene software. We use Scene software to merge all the 20 point scan become 1 point scans. So 1 point scan is the one that you're going to put as a 3D model, okay? So for example, this at the top point, if you look here, is a Hilltop School. It's still used. We went there during the school. So we scan at the external when the students are inside the school. Once they leave the school, and then we can scan in the interior of the building. Okay. If you look on the left side, this is what we call as point clouds. This one. Yep. Point cloud, you see there's a dots, right? That's what we call point clouds. And similar to the second one and also the third one. Okay. Later I will show you through the recap itself so you can see a bigger picture. Okay. And if you look to the next to the point clouds, this is not from camera. This one is also from the point scans, point clouds, but it already converted into photogrammetry. And because we already reduced the noise reduction, and we insert the photogrammetry, and it becomes like a full picture. Okay. Okay, this is an example of the one that we have scanned. This is what we call Johor Bahru Old Chinese Temple, the oldest Chinese temple in Johor in Malaysia. Okay, so if you look at the bottom on the left side, okay, the number of scans is 20 scans. We only did for 1 day, all right? For each scan, involve 5 minutes, okay? So 5 minutes times 20 scan, about 1 or 2 hours. It looks 1 2 hours, but we already spent it like one day because of the people coming and out. We have to wait for a while, and then the others. So the total of point clouds there is 149 million pounds. Sorry, pounds, points. So in terms of RM, it's a 21 gig. That's why in HBeam, one of the challenges, okay, or maybe one of the characteristic, right? Characteristic that you need a high spec computer, right? Even for the one building, it already consists of 20 gig. Okay. Okay, the next one is Johor Art Gallery. Okay, this one that I show you. So this is the overall of point clouds. And if you look at the bottom, number of scans is 43 scans for 1 day only. And the project point clouds about 275 million points. Okay. There you go. Okay, a part of heritage building, HBM also can use for the existing building structure. So this is the laser scanning that we've used, Faro and also with the spheres. Okay, 3D laser scanning is an effective approach that capturing detailed geometries of constructed facilities, and also it can produce a as-built information and engineering drawings for maintenance, facility management, and also to retrofit and others. Okay. Okay, the last process is data synthesis. You have done your scanning, you have convert the point scan into point clouds, then now you have a 1-point scan, which you're going to create into 3D model. Okay, this is a sample of National Art Gallery. Okay, so at the top of the, if you look at the photo at the top one is the point cloud. So when the point sent, we link into Autodesk Revit. So once you enter the Autodesk Revit, it become you can see a point scans. And then how you want to create 3D model, what we are doing now, we do it manually. We need to trace back by floor, okay? But now Autodesk Revit already come up with the as-built interface. If you look at the new Autodesk Revit, they can come up with automatically 3D model, and then you need to make the touch up a bit to ensure that it can look like a full 3D model. Yep. So I show you this is as built. Just a moment. This one. Okay. All right. Okay. Now I'm going to share you some of my the point sense from the RCP Autodesk Revit. Okay. Can you guys see this? Oh yeah, mute.
Yes,
sorry.
we can. Yes.
Okay, thank you. Okay, all right, guys. This one is a Balaisini Art Gallery. So this is what we call point clouds. Okay, you see the dots. Okay. Now we are using Autodesk Recap. Okay, it can be any architecture software, but we are using Autodesk Recap. So from this point scan, if you look here, this is a point scan. Okay, we put our scanner here and it scanned the building. For example, I click this one. I have to wait for a while. So, oh, okay, this is the building. Okay, okay, we go back. For example, just a moment, because of the, okay. Just can't click, is it? Okay, sorry. Okay, this is the points, the building points clouds. So from using a recap, you can go into the building itself. So let's say I'm going now. It's the best when you use a virtual reality, right? When you use virtual reality, it looks like a real. You're playing games inside the house. Okay, so now I'm in the house. You can see that this is an abandoned museum. If you look closer, the condition of the house. Okay, sorry, because lagging. Yeah, this is inside of the building. See, for example. Okay. Now from the recap itself, actually you can do some measure. So let's say you are QS, you want to do some remeasurement. So you can just measure the height of the building. Yeah. Okay. It's a very the accuracy is about 0.01 millimeters, so it's quite accurate. Okay. And then let's say if you want to measure the old building, heritage building, you don't know what the size of the old door, right, length or height. So with the software that we have now, we can use it and to get the height of the door. For example, like this. So the height of the door is 2.7. Okay. Okay, the next one, so I show some others as well. This is a Chinese temple. Okay, it's in the middle of the city. Okay, surrounding by the high-rise building and the only Chinese temple. Okay, so all right. See, if you look closer, the detail of the point clouds itself. Okay, just a moment. Sorry. Okay, right. This is a point, for example. So you can move on. Okay, a bit slow. Okay, right. So the next one is the, sorry, Hilltop School. It's a school, the one that we scan. All right, just a moment. Okay, this is the exterior of the building. Okay, and we can just go inside to see the interior of the building. So this is a I think secondary school. Sorry, kindergarten school. Okay, so just some sample. Yeah, just 1 minute. Just a moment. Okay. All right. So the output of the digital approach. So just now, Mei Chuan already explained about this principle, identification, documentation, and preparation. So the output of overall digital approach is of the micro level and a macro level. So in macro level, you can build an as-built information. So based on redesign, cost estimation, and 3D printing as well. So in the macro level, okay, the more important is to increase the awareness of the conservation. So yeah, us as even though we are not conservator, right? So we as a part of a construction industry, we have to ensure that to maintain and to protect our heritage building from demolition from the government, okay, and also to ensure it for benefit to tourism as well, and also for our younger generations in the future. Okay. Okay, I will show you some example case study from international. So HB International, the first one is the Parma Cathedral in Italy. Okay, so the Parma Cathedral in Italy. Okay, this one. Yeah. Okay, the Parma Cathedral in Italy. Okay, they did a scans. This one, about 20 scans. Yeah, about 20 scans exterior and interior of the cathedral. Okay, and then this is what they come up as a point cloud after registration. Okay, and then they come up with the photogrammetry, and then it's a 3D model in Revit software. Okay, so the second international project case study is Catejo del File Inija, Emilia, Spain. I hope I pronounced it correctly. Okay, this is an abandoned building. Okay, have been left for like 40 years ago. So the purpose of they doing the HB is they want to sustain the building itself. Okay, but the problem is now they cannot enter into the building. So how they scan the building? How they want to scan the interior of the building? So in this case study, they are using UAV, or what we call it as unnamed UAV, unnamed aerial visual, okay, which is a drone, or we call it as a drone. Okay, so they use the drone to capture the building, the interior building. So if you look on the right side, 8 targets of ground control point, okay, has been used as a point scans, and they use an example of target checkerboard. Okay, like our case study, we are using sphere, but they are using target. Okay, so it's a sphere, and then after they they come up with the whole 3D perspective, and they can use analyze. Okay, you can use analyze the the lights, okay, the roof, okay, and others. And also they come with 3D rendering. Okay. Okay, the next one is the Nasib Historical House in Jeddah. So the purpose of their doing HB is they want to make this building to a museum. Okay, this is an abandoned building, so they want to create this building to a museum. So they did a scanning, laser scan. So they come with the point clouds tool, 3D model, and also rendering model. Okay. So the next one, Santa Maria dei Mircoli Church in Venice, Italy. Okay, this one's a very different. It's like kind of new method to scan the building because the building is itself situated on the water and surrounding the water. So in order they want to avoid from the flood, they are using GIS. Okay, GIS, which they focus on the geopreferencing. They focus more on the Google. They're using Google Map, okay, or they're going satellite. So there are many tools. There are many ways to scan the building, not only using laser scanner. All right. Okay, now I'm pass to Mei Chuan.
Now let's move forward to the way forward of heritage buildings conservation. Just now we have shared what we have done in Malaysia, Johor Bahru State mostly. We are using the 3D laser scanner. While we have also shared what have been done globally. Some are using drones, some are using GIS or satellite. So in future, what we are planning here to do is to have different approach. The first one is VR. So this is what we have actually carried out using VR, virtual reality, that allows visualization without the need to be physically at the site. It is an advanced technology that offers better, accurate, and reliable measurement, and it has also avoid some issues relating to health and safety. It gives us real experience in investigating defects and required maintenance. So from VR, from what we can see from the photo, we can visualize the building itself internally, externally, without having us going to the site. And the next approach that we can actually use is augmented reality, AR, different from VR. It handles H-beam with portable devices with the aid of technologies. Basically, we use handphones, okay? Just a handphone will do. This improved collaboration among professionals like architects, archaeologists, restorers, historians, conservators, engineers, and others, using these handphones or other portable devices as convenience entities. Because these portable devices are able to connect people to heritage, to create knowledge, preserve the resources, and enhance visualization. The next one is actually 3D printing. 3D printing is actually a digital control sequential layering of materials to create 3D shapes. Now we have been mentioning quite a lot of times about 3D laser scanner and then 3D models. This 3D printing is actually printing something in 3D useful for prototyping, create highly customized building components. What you can see is whatever it prints, it can be scaled to the scale that is required. It facilitates complex and sophisticated design, but it has some challenges. We have tried some small items. If you look at this, the 3D printer creates the vase that we are holding it. Okay, so this is 3D printing technology. So the process is actually simplified into a 3D modeler that, okay, let's look at the process is this, where we have the model acquisition itself, in which the dimensional data of an intact historical building component is directly measured using 3D laser scanner. We still use the scanner. Then the point cloud data is inputted into the reverse engineering software, which automatically turns into PCD and into a 3D solid model. Then we use program generation, stereolithography file, STL, stereolithography file, that is formatted into a solid model and imported into a data processing module of the system. This is used to generate a machine control program in accordance with hierarchy algorithm for model slicing, and modified stem line algorithm from nozzle path planning. So from here, we can actually generate the program and select materials. Next is the printing itself that takes a lot of time too. The control program coordinate the machine movement and cement mortar extrusion so as to layer the construction of the component. The vase itself that we can see from the previous photos takes us more than 8 hours.
Yes, it can,
Yeah,
be up to 16 hours.
yes,
one
yes.
day.
The vase, it looks small, but then it takes quite a long time. And lastly is the component installation stage, where the printed component is post-processed or polished and installed to replace the damaged one on the historical building, then finalize the reproduction process. So these are the 4 main stages in 3D printing. Okay, lastly, we are going to share with you some of the videos and some on the historic building information modeling HBIM that is actually on the move. Okay,
so
let's
see what happened on 15 April. I hope everyone knows. Okay, this is a North Dam in Paris. So on 15 April, there's a fire, and the spine of the building, okay, it's been, collapse, and also it affects some of the roofs.
Yeah, we hope everyone knows the news.
Yes. Okay, so I'm going to show you some of the news. So everyone's worried because North Dam is in a heritage building, right? So they want to rebuild it. So one time there's a news that they come like they already have the 3D model of the North Dam. Okay, there's a one late art historian already scanned the building 2 years, I think 5 years before this happened. So right, so this is the news, some of the news that have been around the world. Okay, all right. And then the latest news is on July of 13 to 2020. You know, because of the lockdown, they have to stop all the construction. Now they finally continue back the construction. Okay. So we go to the next one. All right. I'm going to share you this. Okay, this is the lead historian, Dr. Andrew Tallon, his name. Okay, so the last one, right?
Dr. Andrew, from what we know that in 2015, Dr. Andrew Tallon actually carried out the scanning. The fire happens in 2019. Actually, Dr. Andrew passed away in 2018. Yeah. So just a few months before the fire. It's November 16th. So it's few months before the fire he had passed away. So luckily he had done the scanning part.
Okay, and the last video for today's session. Oh, sorry. Hmm. Okay, this is how the Faro laser scan looks like. Okay. 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 So then.
Okay, so what the scanning has been done was using the Faro scanner, which is similar to what we have used. Okay, it is a 360 rotation scanning, which takes points. Okay, so before the end, we would like to acknowledge the two researchers who were also helping and assisting us in the case studies. And thank you very much for your time today.
Yep. Okay, and of course, for our further research, we will focus on more point clouds and the importance of photogrammetry and with the 3D model.
Okay, thank you very much.
Thank you very much, everyone.
Vola, we pass it back to you.
All right, thank you, May. Thank you very much.